The multiverse theory explains simply. Look around you. Everything you see feels complete. One universe, one reality, one set of physical laws. But modern science suggests something far more surprising. That our universe may be only one of many. Not imagined, but mathematically possible. Not proven, but seriously studied. This is the multiverse theory. And this is what it actually means. 1. Why scientists began questioning a single universe. For centuries, science assumed the universe was unique. There was one cosmos to understand, one origin to explain, and one set of physical laws governing everything. That assumption began to change in the 20th century as physics explored reality at its deepest levels. The equations describing nature started to suggest something unexpected. Our universe may not be the only possible one. 2. What the multiverse is, in simple terms. The multiverse is not a single theory. It is a collection of scientific ideas suggesting that multiple universes may exist. Each universe may have different properties. Our universe could be one example among many. These universes are not necessarily connected. They may never interact. They may be forever unobservable. But mathematically, they are allowed. 3. The quantum origins of the idea. One of the earliest multiverse ideas comes from quantum mechanics. At the smallest scales, particles behave unpredictably. Events are governed by probability rather than certainty. To explain this, physicist Hugh Everett proposed the many-worlds interpretation. According to this view, every quantum event produces multiple outcomes. Each outcome exists in its own universe. Reality does not collapse, it branches. This interpretation does not add new equations. It simply takes existing equations seriously. 4. Why many worlds is taken seriously. Many worlds remains controversial, but it is respected. It solves certain problems in quantum mechanics. No mysterious collapse of wave functions. No special role for observers. Complete mathematical consistency. Its weakness is not logic, but testability. We cannot currently observe other branches. 5. The multiverse from cosmology. Another path to the multiverse comes from cosmology, the study of the universe as a whole. Modern inflation theory suggests that shortly after the Big Bang, space expanded extremely rapidly. In some models, inflation never fully stops. Different regions stop expanding at different times. Each region becomes its own universe. These are called bubble universes. Each bubble may have different physical constants, different particle properties, different cosmic histories. Our universe could be one bubble among countless others. 6. Why physical constants matter. The laws of physics appear finely tuned. Small changes in constants like gravity or electromagnetism would make stars, atoms, and life impossible. The multiverse offers one possible explanation. Many universes exist. Most are unstable or empty. We exist in one that allows observers. This is known as anthropic reasoning. It does not explain why the multiverse exists, but why our universe looks the way it does. 7. The mathematical universe idea. Some physicists go further. They propose that all mathematically consistent universes exist physically. In this view, reality is mathematics. Existence requires no special cause. All possible structures are real. This idea is speculative, but it follows logically from certain assumptions about mathematics and physics. It remains debated. 8. What the multiverse is not. It is important to be clear. The multiverse is not science fiction storytelling, proof of alternate versions of people, a theory of travel between universes. There is no evidence of communication or movement between universes. The multiverse is a theoretical framework, not a confirmed discovery. 9. The limits of scientific evidence. Science depends on observation and testing. By definition, other universes may lie beyond our observable horizon. This raises a serious question. Can something be scientific if it cannot be tested? Physicists disagree. Some argue that indirect evidence is sufficient. Others argue that untestable ideas belong to philosophy. The debate remains open. 10. Why scientists still study it. Despite the uncertainty, scientists continue exploring the multiverse because the mathematics leads there naturally. It helps explain unresolved questions. It offers consistency across theories. Most importantly, it challenges assumptions, and science advances by questioning assumptions. The multiverse may exist, or it may not. What matters is not certainty, but curiosity. The idea forces us to rethink reality, uniqueness, and our place in the cosmos. Our universe may be rare, or it may be one of many. If this explanation helped clarify one of science's biggest ideas, consider liking the video and subscribing to Interesting MindHub. Because understanding the universe begins with understanding the questions we dare to ask.